indicates rainfall runoff block. For a given rainfall, it will calculate what is the runoff and how much is the overland flow. For the transport block, as again the name indicates, it takes into account the water that is flowing into the conduit or the open water system there, how it is transported, and external block is the extended transport block. It also takes into account the routing, whether it is a kinematic routing flow or whether it is a dynamic routing flow. Storage and treatment block concerns with any other storage systems present there, or a reservoir present in the system, and there is a water quality block as well, which deals with the for the given rainfall, what is a pollutant built up, wash off, and street cleaning and other things. There is an additional features which is the LID, that is low impact developments, which is in the present version of SWMM. It deals with if a user want to install a rain garden or a rain barrel or a rainwater harvesting system in the catchment, how will the runoff peak reduce? What will be the response of the catchment to it? It can be designed, and then the variation can be checked. So coming to literature review, SWM, there are many papers available on SWM throughout the world. So most of them have dealt with BMPs, that is best management practices, and LIDs, that is rain gardens, rain barrels. They have installed them, they have designed for it in their catchment and checked the runoff peak. They have calibrated and validated these models. And they also have done sensitivity analysis, where Manning's coefficient is one of the critical sensitive parameters. They have also compared various EPA softwares like HECMS and SWM. On all the papers, SWM has performed reasonably outstanding to other softwares. Gaps in the literature. Most of the literature papers reviewed with the best management practices and LIDs, and but they have not performed much on the adequacy analysis of the existing system, and much of the studies did not deal with the response of the catchment to various rainfall events. So this is a study area. Here we just explored the applicability of SWMM to the campus of BITS Pilani, Hyderabad. The terrain conditions are Hyderabad, as it is a plain terrain. The elevation is about 500 to 520 meters. This area is about 200 acres with 60% of built-up area and 40% barren land. The data sources which I have collected is rainfall data from IMD 1978 to 2007 and storm network details. So this is a BPHC campus. Google it. So I have all the required data, that is the subcatchment data, the conduits data, and the junctions data have been input. For subcatchment, the input data which I have given is percentage imperviousness, slope, width, and length of the catchments. These I have processed from the Google Earth and using ArcGIS. And for the node, wherever there is a node, the details are what is the maximum depth of the node, where is the outfall, and the inverge elevations at various levels. So, and for the conduit, what type of dimensions am I following? There are several options in the SWMM code. So, we are having a rectangular open channels in the campus, cemented rectangular open channels. So, all these details I have input, and I have divided the area into subcatchments based on the outfall or based on the drainage, stormwater pattern. So, these are the figures from SWMM. This is the campus. It has been divided into 18 subcatchments for every junction, for every node, and every conduit. The open channels. I have given the input data at various points. So the complete campus, which I have shown you initially in the Google Earth, have been divided into 18 subcatchments, and this has been modeled for once in 5 years rainfall data. So flow routing and rainfall method have been used, and infiltration method is curve number, and routing is dynamic routing. The other methods can also be used as well. So the complete drainage model consists of 18 subcatchments, 112 conduits, 95 junctions, 1 outfall, and 1 rain gauge station. So the outputs which I have achieved are total peak runoff, total runoff from various catchments, infiltration, evaporation, scatter plots comparing various catchments for various scenarios, and hydrographs. I can here compare the runoff pattern for 6 catchments. We can see how is the pattern. The runoff is increasing to about 35 to 36 meter cube per second, and it is gradually decreasing along an elapsed simulation time of 24 hours. It is for a day. Similarly for catchment 7 and 12 and 13 and 18. So when I plot a graph comparing, I can come to a conclusion that for catchment 4, the peak runoff is 47.8, and for catchment 13 and 16 it is 31.54. And there is no nodes of flooding. If there is a node of flooding, we will get to know that which nodes are flooded at which levels. This also can be given in SWMM. But there is no nodes are flooded for this rainfall. So from this I can conclude that the drainage pattern is well planned for the campus, and there is no solid waste dumped and no encroachment. So all are there in the initial construction levels. How it is performing in the same capacity. So this I acknowledge ITRA and Facilitate Manager for the drainage plan, and EPA and Google Earth for the softwares. Thank you.
Questions, please. Anybody? Okay, I will ask one question. You have been using word catchment.
Yes, sir.
But you know in hydrology, let's say hydrological unit, and there's a